would like to take this opportunity to first invite our first speaker, Dr. Barb Crawford. Dr. Crawford earned her Master's of Science at the University of Calgary and her doctorate in Geography and Environmental Studies from Sir Wilfrid Laurier University. She serves on numerous boards within the technology and not-for-profit sector. And so without further ado, allow me to introduce Dr. Barb Crawford.
Thanks, Graham. For those of you who don't know me, I'm Barb Crawford, President and CEO of Cybera. Graham's right. I did get my PhD. It was mostly in spatial stats before data science was cool. So I'm sure I couldn't keep up with our participants today by any means, because that was, 11 years ago now. So technology has certainly outpaced my knowledge in this space. I'm really excited today to join all of you and our finalists for the Bridging the Connectivity Challenge closing event. Is actually one of my favorite pieces of this, is to see all the hard work presented back to us after a big effort. But before I begin, I'd like to take a moment to recognize our partners and supporters of this event. First, ISAIC, who has co-hosted this hackathon with Cybera. Thank you, ISAIC. I'd also like to thank the rural municipalities of Alberta and Sierra, who have provided data sets used by the hackers, as well as expertise on the issue of rural connectivity itself. And additionally, I'd like to thank our 5 judges. So Michael Lamoureux from the University of Calgary, Warren Noga from the RMA, Pierre Boulanger from NIAID Labs. Sorry if I said that incorrectly, I apologize. And Lindsay Still, of course, from ISAIC, and our very own VP of Technology, Barton Satchwell from Cybera. Thank you. Thank you to all of our judges for participating and being involved in the hackathon. For those of you who are not familiar with Cybera, we are the Alberta partner in Canada's National Research and Education Network. And so as one of the NREN and Canada's NREN, we work with our Canadian counterparts to connect local researchers, educators, and innovators to each other and to data, technology, and colleagues around the world. So we truly are part of a global network, which makes it a lot of fun and very cool in terms of the opportunities that we can do from the role that we play in the landscape. So for over 25 years, we have provided networking infrastructure and services to the research and education space. And so frequently, we also work with the technology community in Alberta to help foster and encourage innovation, including through data science workshops, fellowships, and hackathons like this one. And that advancing tech talent aspect is really important to Cybera from our provincial mandate. So for over the past 4 years, our Data Science for Albertans program has encouraged the adoption of machine learning and AI and data science within Alberta businesses and the public ecosystem. So the more that we can advance this in this space, the better for all of us. I truly believe that from advancing the technology agenda for our province. And we really believe that the tools and best practices will help grow our workforce and diversity within the economy of Alberta. And this can also be key to solving so many of our problems in our communities, as well as the challenges we face with rural and remote connectivity that we're here talking about today. So this is why I'm excited to join you all today to see what kind of creative options and discoveries the teams have come up with and produced. A reveal day is always exciting, and in my opinion, I'm really looking forward to it. And for the teams, whether your solution supports a better way to advocate or raise capital or enables more communities to get better connectivity, we know that your creative feedback could be the thing that helps jumpstart a new solution or a new way of thinking about tackling this challenge in our province. So it is really exciting. The pandemic has really shown us how the lack of connectivity impacts all of us in terms of participating in the digital economy. And like one of my personal challenges is, how can we help solve and close the homework gap? How can we lessen the digital divide? And those things are really important to Cybera as an organization. So overall, I'd like to thank the hosts and collaborators for sharing their knowledge and experiences on this issue with everybody and with us today. And for our participants, we hope this experience will support your career goals. And we also hope that you learned something and have enjoyed working on the projects that you've focused in on. I thank you again for your participation and all the best as you carry on your data science journey. So with that, Graham, I believe we pass it along.
Yeah, absolutely. Thank you. Thank you, Dr. Kara. Lindsay Still is skilled strategic partnership management and is skilled in strategic partnerships management and leadership. She has a bachelor degree in biology from the University of Victoria. As a member of the Advanced Research Computing Working Group, Lindsay also co-authored a position paper on the ARC needs in Canada as requested by the federal government through the Leadership Council on Digital Research Infrastructure. She serves on numerous committees and boards supporting research and innovation. And we are happy to bring her or to have her here to bring greetings on behalf of ISAIC. Lindsay.
Thank you. Actually, I'm going to introduce my colleague, Jim. He is going to present on behalf of ISAIC as I'll be presenting the award later on. So apologies for that miscommunication. And Jim, I'll leave yourself, or I'll let you introduce yourself and thanks.
Thank you very much, Lindsay and Graham. I'm also, like Lindsay, with ISAIC. We like to think of ourselves as your friendly neighborhood cloud provider, committed to providing resources to Western Canadian-based small to medium-sized enterprises, high computing resources to help further their journey in adoption of AI and machine learning. I'm a technology manager with ISAIC, and I think mostly, much like Barb, many thank yous to go over today. Most notably, we were very pleased, of course, to partner with Cybera on this interesting challenge, and many thanks to the hardworking colleagues at Cybera that were very well organized and kept us on track, and that's Graham and Byron. So thank you, gentlemen. Thank you very much, of course, to my colleagues, in particular at ISAIC, Omid Haja Hassani, Griselda, Lindsay, and others working behind the scenes. Omid was in particular instrumental in providing the infrastructure to help support the hackathon participants and delivering workshops as well. Other thank yous, let me check my notes. Oh, yes. I would be remiss if I didn't mention the couple of clients that stepped up and provided some sessions to help folks understand some of the challenges working in rural areas, and that's NIAD Labs and also Precision AI, a couple of clients that ISAIC is working with. And I think mostly a big thank you to the hackathon participants. I'm sure that you put in many, many hours of work and creative thinking as you approach this challenge. So thank you again for your participation. And Graham, I will turn it back over to you.
Perfect. Well, thank you so much, Jim. So as both our introductory speakers alluded to, over the past 4 weeks, data scientists from across Alberta and some even from across Canada have been working with data supplied by CIRA and the rural municipalities of Alberta RMA to solve two goals: use the available data to assess connectivity barriers and gaps that exist throughout Alberta. This includes identifying communities that are underserved, and assess the correlation between social and economic indicators and the speed of connectivity to determine the role high-speed internet plays in community sustainability. The projects are going to be were judged based on 4 criteria, which looked at social impact, creativity and resourcefulness, communicating your project stories, and technical proficiency, implementation, and feasibility. So over the course of 4 weeks, the hackers heard from experts in academia, industry, local community leaders from across North America about the work that is being done and how gaps impact the fabric of our communities. This helped them contribute to the work that they have done. So today we'll be presenting awards in 4 categories, but before we begin, we're going to take the next 15 minutes to review the 4 finalists' presentations and see what ideas they have to solve the connectivity challenge.
My name's Keenan, and I'm going to just take you quickly through Bridging the Connectivity Challenge Hackathon and kind of what I did for it. So I chose to look at employment insurance. Here I'm showing a graph of employment insurance by age group. I took a look at this because I wanted to kind of address the main goal, which is understanding the socioeconomic impact of internet, especially with a view to kind of rural Alberta and what's happening there. Hopefully by the end of this, you'll also see that I'm working on identifying the underserved areas as well. I chose EI because of its spatial resolution and report frequency. So it's reported every month and it's broken down by census division. And so there's a good number of those in Alberta, and you'll see a map a little later that kind of shows you what those look like. Just flipping through here, you can see that EI is broken down by sex and by type, by benefit type. And finally, we land on this last graph. And this is just, I wanted to highlight what we're not seeing here. So what you'd expect to see is that in March, when COVID first hit, employment insurance would go up, but it didn't because there was another program called CERB. So what I needed to do to complete my analysis was basically to add CERB into the employment insurance. The way I chose to do that was through a discontinuity analysis. So CERB, the best resolution you can get on that is a provincial readout by age group. So I'm basically exploiting the differences in how much EI claimants went up when the program ended. So people were moved off of CERB onto EI. I'm exploiting that difference in order to get basically an estimate for each area what their total EI and CERB counts were. As I said before, I was going to show you a graph or a map, and this is the census districts. And here is all the internet data plotted, so RMA, MLab, and the UCLA data. So I basically need to spatially join all of that and put a primary key, which is the key of the census division here. Just want to show a quick graph too of the download data. Overall, it doesn't move around that much, even kind of year on year. So not a lot of variation here, and then a lot of variation in the variable we're trying to explain, which is why we exploit that difference across regions. Finally, just a quick table that shows the differences between the MLab and RMA data. I ended up going with MLab, but I think there are differences enough in these that it's probably pretty hard to merge them. I'll be interested to see if another team tries to do that. One other thing I just wanted to mention too is in order to get COVID data, I had to merge in basically health regions, and I did a union with the census division. So those are allocated based on their total area within the census division. So some health regions obviously will be split between census divisions. Looking at the panel data now, this was the approach I wanted to use. So looking at the different districts across time. And so I'll just do a quick flip through here. This is the value I'm trying to explain here, the EI and CERB together. I'm looking at some of these 4 internet metrics, and then looking at kind of the average level of education in the area, along with the percentage of rural, and then the monthly active cases of COVID. And then I just put one final rural internet interaction term here. So interacting between some of the internet variables and the rural percentage. Just looking at some of the results here, I estimated a pooling OLS, a fixed and random effects model, and then used a Lagrangian multiplier and Hausman test to decide which one was best. Turned out that random effects was the one to go with, and I'm showing those results here. So in general, it looks like things are moving mostly in the right direction. The better internet is, the fewer EI recipients there are. The only significant variable that doesn't really move in the right direction is COVID cases, and that might be because there's some difference in the actual COVID cases versus the legislation that caused lockdowns. So with that, that's kind of a brief run through of what I did. Thanks very much for your time.
Hello everyone, my name is Ming and my group member is Mong Miao. We're happy to give you an introduction about our hackathon project. So the project goal is to first find the collectivity barriers and the gaps between different counties of Alberta A second goal is find a correlation between social and economic indicators and the speed. We use data from Ocala RMA data and Alberta municipal boundary file. So we first plot the tested internet results of the Ocala to all the counties of the province. And we plot the city area and the rural area. We found that most of the tested results located in the city part. We also plot the house download speed of 2020 of all the counties. And from the Power BI results, we can find that the top for the 2018, the top three county with high speed is County of Santa Paula, County of Wembley River, and Woodlands County. And we also find some counties with quite low download speed, list and all these values. So in detail, we also plot the histogram images for different countries, and we see how the download speed will distribute at the different regions. And these are 5 countries with larger range of download speed, and these 6 countries with the lowest value and also the lowest number of tests. We also plot how the internet speed will change with time. So from red to blue, the internet speed is increasing. Finally, we also plot how the family income will correlate with the download speed for the 34 counties. And we see in general they have the similar trait, which means a higher download speed correlates with higher income. However, there are some exceptions like Lamont County and Starland County, Wankan County, and Woodland County. They have lower income but high speed. And also for Lawson Sunrise County, they have lower speed but still high income. That's all for our report. Thank you so much.
We are a team consisting of 3 colleagues, myself, Ravin Thanju, Isabel Nava, and Team Mac. Isabel and myself pivoting career to the data analytics. And our project name is Internet and Prosperity. So this project is hosted by Cybera, ISAIC, and RMA with the support of CIRA, with the main goals that to identify the underserved community in rural Alberta by assessing the connectivity barrier and gaps of internet, and also assess and correlate social and economic indicators and the connectivity to find impact of internet speed in community sustainability and development. And Alberta, you can see Alberta has average internet download speed 26.2, whereas our national average download speed is around 35 to 40. So we have used two methods, mainly SQL and Python. SQL was used for designing relational database and to query, and Python was used for other analysis and mapping. Now I'm going to pass on to this presentation to my colleague Isabel for the rest of the presentation. Thank you. Isabel, you are up.
Hello, for Python data analysis, we decided to use the download internet speed because of this parameter is the most common used by people, and we use Plotly to graph the difference on having the 350 counties versus the 25 that we selected with low internet. As you can see, the variability for the 25 counties go through from 1 to 6. Having the next slide, please. In this map, you can see, in this slide, you can see the heat map at the left and the market map at the right that indicates the location of the counties and also the variability of the internet download. That you can see the light blue is 1.38 that is represented by La Cori, and the highest is 5.89 represented by La Beach. The next slide. In our discoveries, we found that the revenue equities for the counties were very low, less than 1%. And in financial, is you will expect it equal or lower around 20%. And the average download speed for the 25 counties was less than 10 Mbps. On the next slide, you can see a correlation. How are the average of the rural versus the countries? And you can see that the cities have higher. The gap between the rural areas and the cities is a big gap. 26 versus 6 is a lot. And in our correlation between population and download speed internet, we found 3 clusters, as you can see on the slide. On the next slide, we're thinking the actual and what could be the future impact that those rural areas might have. And we saw that this low speed internet could be limited the sustainability of those rural areas. Implementing tax incentive to attract big companies is important and is needed. And another third factor that we found is the pandemic has caused people to rely on digital communication more than ever. Our conclusion is that we found that the biggest cause of the low connectivity speed found in Alberta rural areas could be the lack of implementing taxes incentive subsidized to upgrade or build better infrastructure, and the lack of the demographic data as personal income, average age, education make it difficult to get an idea on what percentage of people are most affected for low internet speed. And the 3 clusters that we found comparing population versus download internet speed, we need to dig more on that 3 cluster to see if there are any correlation between these 2 variables.
Well, without further ado, we're going to jump straight to the award presentations. Before I begin, we have discussed and recognized that a lot of the work that went into this was collecting data that we could use through some of the internet speed tests that were collected in the collaboration between RMA and CIRA. So before I introduce Grant Street up to present their first award on behalf of CIRA, I would like to share a video with you all that kind of gives you a little bit more context to what the internet connectivity speed tests that CIRA presents to individuals.
CIRA's Internet Performance Test is the most advanced and accurate speed test for Canadian internet users. It helps you learn about the performance of your internet service. It will tell you how quickly you can send or receive data. But what makes this test so advanced? We have installed equipment in key Canadian hubs of the internet, the Internet Exchange Points, in order to provide you an accurate picture of your connectivity, measuring your actual performance over the Canadian internet and not just your service provider's network. Performance is more than just speed. This test also considers the quality of the data stream, the route your data travels, and the countries it travels through, measuring 100 different attributes regarding the health of your internet connection. It might seem like you're just running a speed test, but the CIRA Internet Performance Test is much, much more. The test provides you with a little bit of data, but when combined with the tests from thousands of other Canadians, these anonymous results help researchers understand and build a better internet for all Canadians. So what are you waiting for? Begin your test and make the CIRA Internet Performance Test your go-to site for tracking internet performance.
All right, without further ado, I'd like to first invite Grant Street, who is a program manager from CIRA, to present the first award.
Thank you very much. Well, welcome everybody. Looking forward to seeing all of your results, and glad you put in all of this hard work to get us some valuable information. The first award is for the Personal Best Award, and it is worth $1,000. The winner of this award provided a unique idea when addressing the challenge of rural connectivity. This team did a great job leveraging various types of visualization tools, including Seaborn and Power BI, to illustrate their findings. This allowed them to provide a clear and concise comparison of speed test levels from different counties. This project took an aspirational approach at trying to find a causal relationship between internet download speed and household income. This prize is awarded to Team M&M. Congratulations.
Congratulations to that team, and thank you, Grant, so much. And I wish we were in an auditorium so we could hear rounds of applause and be able to praise everyone for their great effort. And thank you to CIRA for their support during this time, and for yourself, Grant, who gave the team at Cybera and ISAIC a lot of insight leading up to this hackathon. The second award is going to be presented by the rural municipalities of Alberta, who's been a critical partner in this project, providing information and context to the project. Many of you may have heard their workshop by the RMA president prior to this presentation. They've been able to share a lot of lived experience that rural Albertans are facing and the challenges that these communities are dealing with. So I'd like to introduce Warren Noga, who's a policy advisor with RMA, to present the next award.
Thanks, Graham. As Graham just said, I'm a policy advisor with the RMA, and I will be presenting the award for the best social impact, which is valued at $1,000. On the judging panel, we were really excited to see all of the innovative ideas that were explored by the teams. And the project we selected for the Social Impact Award explored various data sets relevant to the problem they were addressing. The team built a new data set combining multiple existing files in a meaningful way to address a complex real-world issue. They went on to conduct various statistical analyses that address that important social issue. I would like to congratulate Team Solo for their work exploring how internet speeds impact EI and CERB counts, especially in light of the current COVID-19 situation. Team Solo's use of EI and CERB as a socioeconomic indicator is innovative and has real-world potential to underscore the importance of access to high-speed internet. Congratulations again, Team Solo.
Excellent. Thank you so much, Warren, and congratulations, Team Solo, on winning that award. Our third award will be presented by Lindsay Still. I gave a great introduction in relation to the depth that she was able to bring as a judge here, and the work that she does supporting ISAIC. And so, and as a partner in this program, we're happy to have ISAIC and Lindsay present the next award.
Thanks, Graham. I'm delighted to present this award for Best Technical Implementation. As a judge, it was so hard to choose because all the teams presented unique and impressive solutions when faced with the same challenge. And I just want to say thanks to all the teams. It was so fun to be a judge for this. So it was great to see what you could come up with. The team that the judges selected for this award really impressed us with their unique use of database techniques and access to data, and their excellent use of data visualizations and heat maps to make important points about the data content. They presented a great looking plots using Plotly. It was also great to see some of their analyses employ novel perspectives of looking into the data. For example, their post analysis to find out the clusters, as well as comparing the counties with the cities. So for their innovative use of code, database methods, and SQL technologies, which form a solid foundation for doing data analytics and data science in this new world that Barb is not quite so familiar with, I'm pleased to present Data Dusters with the Best Technical Implementation Award of $1,000. Congratulations, team.
Excellent, congratulations. And thank you, Lindsay, so much for presenting that award. The final award, which speaks in relation to the overall hackathon itself, is going to be introduced by Dr. Barb Crawford, CEO and President of Cybera. And I'd like to introduce her to present that award.
Thanks, Graham. Lindsay, I was just going to say, maybe not up to speed anymore, but once a data geek, always a data geek. I think it's a good thing to say. So the final award is the Best Overall Award, which considers the social impact and creativity and resourcefulness of the presentation. They were able to create a web-based tool that clearly outlined the issues at hand and broke down internet speeds and population by sectors across Alberta. The team went out of their way to ensure they had a tool that was generalizable and not only could be used by experts in the field, but the public as well. So the project has tremendous potential and something that can continue to grow through their visualizations, detailed explanations of cases, and insightful future actions and next steps. The project also has amazing visualizations and a functional website that can be used to support advocacy work now and into the future. So the grand prize winner for the $2,000 awarded prize is to the group whose project had the best potential to have the largest impact in the community, which is Team Bean Time. Congratulations.
Team Bean Time on winning that final award. As we had a chance to see many of the demonstrations and the videos there, one of the judges or some of the judges commented that we'd be remiss to not look in depth to some of these projects and look at some of the GitHub repositories, as there's a lot more information and you actually get to see some of these tools in practice. So following this meeting, we're going to be sharing that information with individuals, or they'll also be on the YouTube links where this event will be posted. And in closing, I'm happy to speak on behalf of the entire team who's very excited about these projects. We see it as a huge jumping off point for many potentials. And so thank you to the hackers who put in a lot of work, and you guys enjoy the beautiful weekend that we have in store for us. Thank you all so much.